Hello my dear children. Children, in the class of gravitation, we are going to study increase in potential energy of an object as it moves up above the Earth's surface or above a planet. At the same time, we will study the escape velocity of an object over any planet. And finally, we will discuss about satellites. So let us know what is the increment in the potential energy of an object as it moves up the Earth's surface. This is, say, a planet or say planet Earth. This is an object of mass m. It is thrown up and it moves up by distance h. So what is increase in its potential energy? We already know that when an object is thrown up, its potential energy increases. We also know the absolute formula of potential energy of an object. When the object is over the surface of planet, its potential energy is what? Minus gmm by r. R is the radius of the planet, capital M is the mass of the planet. As the object moves up by distance h, at this particular point, at height h, its potential energy would be what? Minus gmm upon r plus h. This is greater than this potential energy. UH is greater than US. So what is increase in potential energy? Final potential energy minus initial potential energy. If we substitute these values, what do we get? Minus gmm by r plus h minus times gmm by r. This minus becomes what? Plus. We take gmm as common. What do we get? We get 1 upon r minus 1 upon r plus h. If we solve this quantity in the bracket, we get what? R plus h minus r upon r times r plus h. Children, let us multiply this by r and divide it by r in the denominator. And in the numerator, we can see that this r cancels out with this r. So what do we get? gmm into h. gmm into h. And in the denominator, we get what? R into r is what? R square, and this r upon r is 1 and h upon r is h upon r itself. So this expression is simplified as gmm h upon r square 1 plus h upon r. And gm by r square is nothing but acceleration due to gravity over the surface of the planet. Say g. So this quantity gm by r square is the acceleration due to gravity over the surface of planet, say planet Earth. So we can write this numerator as mgh, and the denominator is 1 plus h upon r. Children, we have been using the very popular formula of potential energy, mgh. When the object is at height h, we say its potential energy is mgh. But remember children, mgh is not potential energy. mgh is not potential energy. So what is mgh and under what condition the potential energy is mgh? Let us know that. See, when an object moves up by distance h, and if h happens to be much more smaller than r is the radius of the planet. If the height up to which the object moves up is much more smaller than radius of the planet, then what happens? h upon r is much more smaller than 1, and that is nearly equal to 0. Since h is much more smaller than r, so h upon r would be nearly equal to 0. So this ratio is going to be nearly 0. So what do we get? Delta U is equal to mgh. So what is this mgh? This mgh is not potential energy. This is increase in potential energy. So the formula of potential energy which we have been using as mgh is not the formula of potential energy. It is the formula of increase of potential energy. And that too when object moves by distance h, and h is much more smaller than r, the radius of the planet. If we talk about Earth, well, the radius of Earth planet is what? 6,400 kilometer. If object moves by few hundred meters or even few kilometers or even few hundred kilometers, even then h is much more smaller than r. In that case, we can say yes, as the object has moved up by distance h, its potential energy increases by mgh. Remember, mgh is not potential energy, it is increase in potential energy. An absolute value of potential energy we have already studied. What is that? This is the value of absolute potential energy minus gmmr by r, that is over surface, and this is at height h. So this is increase in potential energy when object moves up by distance h, and h is much more smaller than r. Now see, if object moves up by distance h, h happens to be equal to r. In that case, this ratio would be 1. If this ratio is going to be 1, what is increase in potential energy? mgh upon 1 plus 1 is 2. This is mgh by 2. Children, let us know what is escape velocity. Escape velocity over a planet is the minimum velocity or minimum speed with which, when an object is thrown, it just not return. The speed with which we throw an object over a planet so that the object just not return is called escape speed or escape velocity. So this escape velocity is constant for a planet, and different planets have different values of escape velocity. Well, moon has no atmosphere. At the same time, escape velocity over the surface of moon is very, very small. Therefore, what happens? Even the gases from the atmosphere of the moon, they escape, because this molecular speed of the molecules of the gases is greater than the escape velocity over moon. So why moon doesn't have atmosphere? That is what I am telling you. The escape speed is smaller than the speed of the molecules. So molecules what? Escape from the surface of the moon, as the real moon doesn't have atmosphere. Well, what is escape velocity over, say, a planet of mass m and radius r? This is planet of mass m and radius r. So escape velocity, minimum speed with which, when an object is projected from a planet so that the object just not return, is called escape velocity over the planet. Well, if an object is here over the surface of the planet, as the object is thrown away from the planet, it moves up, and as the object moves above the surface of the planet, its potential energy increases. Potential energy increases, but at the same time, kinetic energy what? Decreases. And if this kinetic energy decreases and becomes zero anywhere in this is the boundary of, say, gravitational field of the planet. And if the kinetic energy becomes zero anywhere in this region, which is the sphere of influence of the planet, the object will come back because of the gravitational force of attraction. But if the kinetic energy decreases and becomes zero when the object just moves out of this boundary, when the object just moves out of this boundary, which is the gravitational field, when the object moves out of this boundary, then if its kinetic energy becomes zero, what will happen? The object would not return, because when it moves out of this region of influence of the planet, it is no more attracted. So if kinetic energy becomes zero anywhere in this region, the object will return back to the planet. But if the kinetic energy becomes zero when it is just outside this region of influence of the magnet, this gravitational field of the magnet, gravitational field of the planet, it would not return. So let us find out the escape velocity by conservation of mechanical energy. When the object is over the surface of the planet, its kinetic energy is k1, its potential energy is u1, and as the object moves away and moves out of the sphere of influence of this planet, its kinetic energy becomes k2 and potential energy becomes u2. By conservation of energy, K1 plus U1 is equal to K2 plus U2. What is K1? K1 is the escape velocity, and what is that? VE. So kinetic energy is what? 1 upon 2 mVE square. We are finding out K1 when the speed is what? VE. So this is 1 upon 2 mVE square, kinetic energy over the surface of planet, and potential energy over the surface of planet is what? Minus GMM by R. What is kinetic energy finally here? Kinetic energy finally here becomes what? 0. And what about potential energy? Potential energy also becomes 0. See children, something very interesting here. Kinetic energy is always positive. Minimum value of kinetic energy is 0 and maximum value of kinetic energy can be infinite. Potential energy of an object is always negative. Gravitational potential energy of an object is always negative, and the maximum value of gravitational potential energy can be what? 0. So what is happening here? As the object moves from surface to this point, which is outside the sphere of influence of the planet, its kinetic energy decreases to 0 and potential energy increases and becomes 0. So kinetic energy decreases to become 0 and potential energy increases and becomes 0. The maximum value of potential energy is what? 0. Otherwise, the potential energy is always negative. So 0 plus 0, that is the final energy. If we solve this, what do we get? This side changes, this m cancels out. What do we get? V as Gm 2Gm by R. 2Gm by R square root. And if we multiply it by R and divide it by R, then what happens? Gm 2Gm R upon this R into R is what? R square. Gm by R square is what? Acceleration due to gravity over the surface of the planet. So what do we get? 2Gr. This is the value of escape velocity or escape speed over a planet. For planet Earth we know G is what? 9.8. R is what? Radius of the Earth, that is 6400 kilometer, that is 64 into 10 to the power 5 meter. If we solve it, what do we get? 11.2 kilometer per second. So over Earth's surface, the value of escape velocity is 11.2 kilometer per second. And remember, there are certain very important facts. Escape velocity over a planet is independent of number one, mass of the object. Like escape velocity over the surface of Earth is how much? 11.2 kilometer per second. Whether we throw this pen or we throw a very big object, both will have what? Same escape velocity, 11.2 kilometer per second. Whether we throw a mouse away from the surface or we throw an elephant, both will have same escape velocity, 11.2 kilometer per second. And when these objects are thrown, any object is thrown from the surface with the speed of 11.2 kilometer per second, it would not return back to the Earth. Well, so escape velocity over any planet does not depend upon mass of the object. Object may be very heavy or very light. For both the objects, the escape velocity is same. And the second very important fact is escape velocity is independent of the direction of projection. In any direction you may project an object, well, its escape velocity would always be same. It is constant for a planet. Children, let us know very briefly what are satellites. Satellites are the objects which revolve around planet. Satellites are those objects which revolve around planet. There are two types of satellites. These two types of satellites are what? Natural and artificial. Moon is natural satellite of Earth. Miranda is the natural satellite of Saturn. Well, our Earth has number of artificial satellites. These artificial satellites are man-made, and these artificial satellites are of two types. One is called polar satellite and the other one is called as geostationary satellites. What are polar satellites? Polar satellites are the satellites which are very close to the Earth's surface. They revolve around the Earth's surface, but at the same time, we are very close to the Earth's surface. That is why we also call them as Earth satellites. Their distance vary from 300 to 1500 km from Earth's surface. On the other hand, geostationary satellites are far away from Earth's surface, and the distance at which they are above the Earth's surface is exactly 36,000 km. So, geostationary satellites are exactly at a distance of 36,000 km from Earth's surface, and the orbit in which these satellites revolve are called Clark's orbits, stationary orbits. Well, why do we call the orbit of these satellites as stationary orbits? That we'll know very shortly. Well, the speed with which the planet revolves around planet in its orbit is called the orbital speed, and the orbital speed of polar satellite is 7.9 km per second or nearly 8 km per second, whereas geostationary satellites have their orbital speed as 3.1 km per second. Time period of revolution of polar satellites which are very close to the Earth's surface is nearly 84 minutes, and they may move in any direction. But geostationary satellites have time period of exactly 24 hours, and they move from west to east. Same is the time period of spin of the Earth. Earth also completes one spin about its axis in 24 hours. And it spins from west to east. Same is the time period of revolution of geostationary satellite. So what happens? As the Earth rotates and completes one revolution, these satellites also rotates and complete one revolution. So their relative velocity with respect to Earth is what? 0. The relative velocity of these satellites with respect to Earth is 0. That is why these satellites appear to be at rest with respect to Earth. That is why they are called as geostationary. Geo means with respect to Earth, stationary means at rest. So these satellites are at rest with respect to Earth, and they are exactly at a distance of 36,000 km from Earth's surface. So this geostationary orbit lies at a distance of 36,000 km from Earth's surface, and their time period of revolution is same as that of Earth, and in the same direction, that is from west to east. Well, these satellites, polar satellites, are launched by a vehicle, and that launch vehicle is called as PSLV. This is a very popular word you must have come across, PSLV. So what does PSLV stand for? PSLV stands for Polar Satellite Launch Vehicle. The rocket or the system of rockets, multiple stage rocket which is used to launch polar satellites are called PSLV. Whereas to launch geostationary satellite, the vehicle is called as GSLV, Geo Satellite Launch Vehicle. So children, this was a brief overview of satellites, and in the next class we will study in detail what is orbital velocity of a satellite, what is the time period of satellites, and various other aspects including energy of satellite. So this is all for the time being. We will meet again very shortly with greater details with respect to satellites. So this is all. Thank you very much. God bless you all.